This is homework for 2-12-15, Thursday. And tonight you'll notice that there are only two problems. That's not a mistake. I did that on purpose because I'm going to be asking you to do an extra step tonight. So before, all you had to do was write the slope on this line, use its opposite reciprocal to build a square around here, and then surround and subtract and find the area. Now that we've been working on the connection between area and side length, I'm going to ask you to take a couple extra steps. You are not only going to find the area of this, but you're going to write this side length in radical form, estimated, and it can just be it doesn't have to be a perfect estimate, but just an estimate, and in simplest radical form. So you'll give me all three forms for the side length of this figure. Now, I'd like you to turn off the video, and I'd like you to try number one all on your own. And then when you have number one done, you've got the area, you've got the square, and you've got the side length in three forms. Turn the video back on and go ahead and check yourself. Okay, so you don't have to write this down, but you should know that the slope of this line that you started with was 5/5. And so the opposite reciprocal is -5/5, which tells me to go down 5 and to the right 5 from here, and I have to repeat down 5 and to the right 5 from here. Okay, so I have my square. Now, pay attention to what the area of these triangles are, and look how big they are. But it was really easy for me to use area equals 1/2 base times height to get 12.5. This has a base of 5. It also has a height of 5. 5 times 5 is 25. Half of 25 is 12.5. All four triangles are exactly the same, so all four triangles are 12.5 units squared. The big rectangle square that I surrounded this tilted square with has a base of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it also has a height of 10. 10 times 10 is 100. So now I have to take the area of the whole thing and subtract the area of the outside pieces. That's these four outside pieces. And I know that 4 times 12.5 is 50. So 100 take away 50 is 50 units squared. Now I want you to keep watching for a minute because I want to show you this last part, and I'm going to do some writing on the screen, so please don't fast forward. If this is area of 50, its side length is square root 50. Okay? Radical form. Since I know that, oh my goodness, that's not a very good estimate there. I know that 7 times 7, that does not look like a 7. 7 times 7 is 49. And I didn't even check this with my calculator. I know that means that about 7.1, maybe even a little less than 7.1, is going to give me pretty close to 50. 7.1 times 7.1. Okay? Now I'm trying to put it in radical form. And so now is where I want to show you how I did this. And I'll show you first just with numbers, and then I'll show you on the square. Okay, so what I'm doing is I'm trying to figure out what the biggest number is that divides into biggest perfect square. I apologize. What is the biggest perfect square that can divide into 50? The biggest perfect square that can divide into 50 is 25, which means that this is equal to the square root of 25 times 2. Now I can simplify this. The square root of 25 is 5, so it comes to the outside. I cannot simplify this because the square root of 2 is an irrational number. There is no perfect whole number multiplied by itself that equals 2. So I'm going to leave it under here. That's how I got 5 square root 2. Now watch how I can show that this side length, because this represents the length of the side, watch how I can use dividing this up to show you that the side length, and I'll use this side since I've already written all over this side. Actually, I'm going to use this side right here to show you that it really is 5 lengths of the square root 2. So remember that our square root 2's looked like this. Remember they went up 1 and over 1. And so there's 1, and there's 1, and there's 1, and there's my last one. Sorry, those aren't very nice ones. Each of these has an area of 2. Area of 2, area of 2, area of 2, area of 2. And if that's true, then their side length has to be the square root of 2, 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 the square root of 2. Altogether, I have 5 square roots 2, which is what I said the length was over here in simplest radical form. One thing that you'll notice is that any time that you divide this up into the biggest perfect square that can divide evenly into it, you'll have small squares here. They'll be nice and small. If they're too big, it means you didn't figure out what the biggest perfect square number was that could divide into it. Now, before you go to the next screen, I want to remind you it's really important that you try this, all 3 forms of the side length, on your own before you watch the video. Just watching the video doesn't make you smart. You have to watch it, fix your own mistakes. That's how you build those neural paths. So really try to do it on your own before you watch the video and just copy. Okay, turn the video off and try the second one on your own. Now, I'm really sorry that when I put those 2 lines on there, I did not notice that when you build your square, the 2 squares end up overlapping me, and I couldn't deal with that. So I took another piece of dot paper and I drew my square on another piece of dot paper so that it wasn't overlapping with this square that I'd already done, because that drives me crazy. So I apologize for that. I should have been more careful about them overlapping. All right, on this one, when I look at my triangles on the outside, I notice that this has a base of 1, 2, 3, 4, 5, 6, and a height of 1, 2, 3, 4, 5, 6. 6 times 6 is 36, and half of 36 is 18. So my outside triangles are all 18 units squared. Now, the whole thing, the whole base for the square that surrounds my tilted square is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 12 times 12 is 144. So to find this area, I took 144 and I subtracted away from it 4 times 18. 4 times 18 is 72, and when I did that, I ended up with 72 units squared. Now let's look at the side length. This first one is really easy. You should all be able to get this one with no problem. If the area is 72 in radical form, the side length, this length right here, is the square root of 72. Now, the square root of 72, I know that 7 times 7 is 49, and that's too low. And 8 times 8 is 64, and that's too low. And 9 times 9 is 81, which is too high. So I know that it's somewhere between 8 and 9. And I just made a guess as to 8.5. When I checked it on my calculator, it came out to be I think 72.25, which means this is pretty close. This is only 25 hundredths away from being exactly 72. So if you got that close, you did a really good job. If you said 8.4, that's not a bad job either. That's a pretty good estimate of how long this side length is. Okay, now how did I get this 6 square root 2? Let me show you. I know that the square root of 72 is equal to, the biggest perfect square that can divide evenly into that is going to be 36. 36 times 2 is equal to 72. Well, what's the square root of 36? It's 6. And I can't do anything with this 2, so I finalize this to be equal to 6 times the square root of 2. So, simplest radical form, estimate, radical form. Okay, your homework is done. Thank you.